So a complex number is a number with the form a plus bi, where a is the real part and b is the imaginary part of the complex number. If b equals 0, then this whole thing, a plus bi, is just a, which is a real number. If a equals 0, then b is not equal to 0, then the complex number is called a pure imaginary number. An imaginary number is an even root of a non-negative number. So given an imaginary number, the way we express it in standard form is, let's say we have the square root of negative 9, and we want to express this in the simplest form possible. So essentially what we do is we break it down. We know that negative 9 is negative 1 times 9. So we have this equals the square root of negative 1 times the square root of 9. And then we know that square root of negative 1 equals I, and that the square root of 9 is 3. So this is simply 3i. Then, so there's no a to this. So it's just 0 plus 3i. And that's how we write this in complex form. Okay, so some examples for this. We want to write these in the simplified complex form. Let's start with part A. So we have the square root of negative 49, and we can rewrite this as a negative 1 times the square root of 49, and then we can rewrite this over here. We have 2 times the square root of negative 1 times the square root of 9. And then from here we're just going to simplify what we know. We know that this here is I. We know that this is 7. Then we have a plus in the middle. We know that this is I, and then that this is 3. So then we have 7i plus 2 times 3, which is 6i. And all of this would be 13i. And since there's no a, there's no real part, then it's just 0 plus 13i. Okay, similarly, then we're going to do part B. We know that this here is root negative 1 times root 9, and then it has a negative on the outside that is being multiplied by. Then we have a minus, then 8 times negative 1 times root of 25. And then again, we're just going to simplify. So we have a negative 1 times this I here, and then we have a 3. So this is negative 3i. This whole term is negative 3i. Then we have minus 8 times I times 5. So minus 40i. Then negative 3 minus 40 is going to be negative 43i. And again, we don't have a part A. We don't have an A part. Our last example for complex numbers and simplifying them is going to be this 24 plus the square root of negative 32, all divided by 4. So this one's going to be a little longer because it also requires understanding how to simplify a radical. So let's start by breaking this down into two separate numbers. So since we have a 4 in the denominator, this is the same thing as saying 24 over 4 plus this over 4. And we know that this is just 6. Okay, so now we're just going to worry about this. And we can write this negative 32 over 4 as negative 1 over, or times root of 32 over 4. And then we can keep breaking this down as well. We know that this is times 8 times 4 over 4, which is, we can keep breaking that down even more, it being 4, and then 2, and then 4 again, and then 4. So this is essentially just that root 8, just broken down. Okay, then from here, we're just going to keep simplifying. We know that the square root of 4 is 2. So we have a 2 here, a 2 here, and then we know that this is I. So all this just becomes 2 times the square root of 2 times I. So 4 times the square root of 2 times I. All of this over 4. And since we're multiplying everything on the top, we can just cancel these, and then this whole term just becomes that. So then the whole thing together, we have our part A, the real part, which is 6, and then we're adding a root 2 I at the end. And it's important to know that the I is on the outside of the radical, not on the inside.